Good morning, my dear kids. In today's class, in the chapter optics, we are going to discuss the topic, the problems on the prism. So, if you can recollect the previous two classes also, we had the discussion on the problems on the prism. So, we'll further continue with a few more applications on the prisms application. Means like what are the different types of further few more problems. Once again, I insist you on uh, problem analysis. You have to think more on the numericals. Read theory, then immediately jump out to solved example. Then after solving few solved example, then you should go for working out numericals on your own. As you start solving, then the knowledge starts growing. Just mere listening to my lectures also to some extent will help you. But the real engineering skills will develop only when you solve problems on your own. So first, every chapter I'm discussing plenty of numericals, so understand them, learn them, then on your own try to solve the problems. So once you start solving problems, you come to know what actually this prism concept is there. So we discuss the prism, you look at the theory, but when it comes numerical, no, it will take a totally different dimensions, no. So it's all about the learning concepts through numericals. This is what the method is, what I'm insisting. So when clarity of concepts will come, when you work out different numericals, then what happens? The clarity of concepts will come. Hmm? So let me start the class. So three glass prisms ABC of same refractive index ABC are placed in contact with each other as shown, with no air gap between the prisms. Monochromatic ray of light OP passes through prism assembly and emerges here in this way. So the light. Okay, fine. The condition of minimum, where the minimum deviation is, in which particular prism minimum deviation is there. So what is the basic idea for minimum deviation? The refracted ray inside the prism should be parallel to the base. So you can see that this is the base, and the refracted ray here, you can see this one. This refracted ray is parallel to this. Here refracted ray is parallel to this. Whereas here it is not parallel. Here it is not parallel. This is the base of the prism. It is not parallel here. So here it is parallel. So therefore, the ray undergo TIR in the prism A and B. So what is the basic condition? So sorry, when minimum deviation, at minimum deviation, at minimum deviation, refracted ray will be parallel to base of prism. Okay. Next again, this will be very good question. Hmm? I'll take out the video. A ray of light from a liquid mu equal to root 3 is incident on a system of two right angle prisms. The ray suffers zero deviation when emerges into A from CD. Okay, let me draw the diagram. Okay, we have here liquid. air liquid, air air. So the refractive index of this mu1 root 3, mu2 root 2. This angle is 90 degrees. A1, I'll write it. If both A1 equal to A2 equal to 90 degrees. Now what will happen? A ray will liquid refractiveness of the liquid and the first prism, they're same. You check that one. So this condition is something very important. The refractive index of the first liquid and the prism are same. So the ray will go undeviated. Just wait some. The ray goes undeviated. So let me go for the ray diagram. It should go undeviated. Then this is the normal. This is the angle of incidence I. So this should be the angle of incidence I. Then here we'll get a normal for this. Then the ray is here. What is the refractive index of liquid? Root 3, that one. So the ray, what will happen, as though it's a boundary for us, but the medium is same, so the ray will go undeviated. Here it will encounter a boundary. It is moving from denser to rarer, so it should bend away from normal. The ray should bend away from normal. Then again, the ray is moving from denser to rarer. It should bend away from normal. Okay. Okay, this is the. So this angle will be 90 minus I. This angle will be R2. This angle will be 90 degrees. R3, and this is the emergent angle. Okay, fine. This one. So first, what is asking? The ray suffers zero deviation when emerges into air from CD. Okay, this is the CD. This is AB. Net deviation is zero. So what is the total deviation? Deviation suffered. Here there is no deviation. What about here now, the ray? It is moving from denser to rarer, no? So therefore R2 minus 90 minus I. This will be the angle of incidence. So the net deviation will be R2 equal to 90 minus I, E minus R3. So this will be E minus R3 will come. Okay, next this will be R2 minus R3 plus I plus C. The net deviation is in fact zero. Now look at this. Any relation between the angles R2 plus R3 should be equal to A2. And A1 equal to 90 degrees. So I'll substitute here deviation R2. This will be 90 minus R2 minus 90 degrees plus I plus C. So the deviation will be 2R2 plus I plus E. Let this be equation 1. We know net deviation is 0. I have to substitute this one. No? Net deviation is 0. Keep this in mind. So we have to calculate that I. So for that we don't know R2 and E, that one. We'll apply the Snell's law here. Mu1 applying Snell's law at AC. That should be equal to mu1 sine of sine of 90 minus I. mu1 is equal to root 3 cos I equal to mu2 is how much? Root 2 sine R2. Again applying Snell's law. One more, we'll apply Snell's law at CD. At CD, so mu2 sine R3 is equal to 1 into sine. So R2 I can, R3 I can replace as R2. Mu2 is how much? Root 2 cos of sine of so this will become root 2 cos R2 equal to sine. Squaring and adding, this is 1, equation 2, equation 3. So 3 cos square I plus sine square E equal to 2. So this is the equation 4. Okay, now solving 2 and 4 will get the required answer. But we don't know R2. We don't know R2, no. I and D. R2 is unknown thing. So you take help of this particular thing. No? This any relationship can be right here. 90 plus I. So this is 90 degrees. This is I. You draw this particular thing. So what can be this angle? No, if you draw a line, this one. So let me show it. Yes. R2 90 degrees. This is I. So I want you to extend This is total is R2 and this angle is 90 minus R. What can be this angle? So call this is alpha. This is I no. So this will become this R2. This should be this total angle should be higher. I'll indicate this. Here we should search this one. So this is high. This total angle is high. We wanted this particular angle. So what can be this one? This will be R2 minus alpha. This angle will be say some beta you call it. Somewhere I should get some relation between the angles. No? Here I'm trying. This total will be 90 plus R2. 90 plus this angle is R2. This angle will be 90 minus R2. This angle is 90 minus R2. We wanted alpha, no? Here. Alpha plus 90 plus I should be equal to 180. This is 90 minus R2. I'll write down some equations. Huh? Yeah, we'll write it here. I plus 90 degree plus R2 plus alpha equal to 180 degrees. How to bring R2 equal to beta plus alpha? I minus beta equal to 90 minus R2. What is beta? Beta I can write it as R2 minus beta. R2 minus beta equal to 90 minus R. So alpha will be equal to 90 minus R. Okay, we are getting same thing. So this angle is needed for me. Relationship between the angles 90 plus I. Yeah, fine. We are, I think, yeah. Okay, I think no need of this. No need of this. These things not needed. Directly from solving those equations, we'll get the required answer. I'll take it out this one. Okay, solving 1, 2 and 4 will get the answer for I. So what we'll do is like 0 equal to 2. R2, what I can write it as like a root root of 3 by 2 sine inverse of 3 by 2 cos I plus I plus E will be sine inverse of under root of uh, this will be 2 minus 3 cos square I, all this equal to 0. We have to solve this for I, we'll get the required answer. Okay, a little bit lengthy calculation, just I'll share the idea. Huh? Okay, we'll proceed to the next problem. An isosceles prism of angle 45 degree, it is found that when the angle of incidence same as the prism angle, the emergent is greater than emergent. Find the refractiveness of material of prism for what angle of incidence the angle of deviation is minimum. So himself has given diagram. So he's asking to get the refractive index of the material of the prism. Yeah, what is the method? I think already we have discussed some problems of this kind, no? So if you can recollect. First we'll begin with the applying the Snell's law. Sine 45 degrees is equal to mu sine r1. 1 by root 2 equal to mu sine r1. So sine r1 equal to 1 by root 2 mu. Then mu sine r2 is equal to sine of 90 degrees. So what is sine r2? Sine r2 is equal to 1 by mu. We know r1 plus r2 equal to 45 degrees. So r2 equal to 45 minus r1. Taking sine on both sides, sine r2 equal to sine of 45 degrees minus r1. Sine r2 is 1 by mu. Sine 45 cos r1 cos 45 sine r1. So 1 by mu equal to 1 by root 2 cos r1, 1 by root 2 sine r1. We'll substitute all the values. Cos r1, I can write it as 1 minus sine square r1. Sine r1 is root 2 mu. So 1 by mu equal to 1 by root 2. Sine square r1 will be 1 by 2 mu square by 2 mu. Solving this, we'll get expression for mu. One by mu, 1 by root 2. This will be root 2 mu minus 2 mu. So altogether Uh, Solving this, mu will be root 5. Hmm? Right, minimum deviation, what is the condition? R1 at minimum deviation. So now apply sin I1 equal to mu sin R2. Mu is how much? Root 5, 1 by root 2. So angle of incidence will be sine inverse of root of 5 by 2. Okay, we take the next one. Now this is some simple problem. First read the question. A light ray is incident. A light ray is incident on the face AB of prism ABC. As shown, the second prism is kept in such a manner that emergent ray from the prism ABC is falling normally on the face A dash B dash. So here it's a normally. The net deviation produced by the optical system of the two prisms. This is a very simple problem. Let's see that how you light here. So there are basically two prisms are there. Let me draw the prisms. There's a one prism. There's another prism. We'll go for. So there's a ray. First it is incident here. Then this incident normally, no? Yeah, no, no, you can see this. This is the incident normally. It will strike here. Okay, if you can get the ray diagram, you'll be in a far better position. Huh? It will be very easy for you. Okay, let's get the angle of prism. This is 74 degrees, 37 degrees, mu 1, 4 by 3, mu 2, 4 by 3. The net deviation produced by that. But what information we have is that this incident normally, no? We have information that this angle is 90 degrees. So the minimum deviation is there, no? Minimum deviation I have to show it. Now I'll do the correction. Okay, this one. After this, the ray will be incident normally. Then okay. Now getting to the problem. So this angle is given 37 degrees. So this is the minimum deviation. So this angle R1, R2. R1 equal to R2 is will be equal to 74 degrees by 2. This will be 37 degrees. Then we'll get this I1, this I2. R2 is 0. Sorry, R3 is 0. R3 is 0. I3 is 0. This angle of prism will be A1. This is A2. So here, look at this part. R3 plus R4 should be equal to 37. R3 plus R4 should be equal to A2. This is 0. R4, this is 37 degrees Celsius. This angle we can calculate. Okay, then we'll get the total deviation very easily. Deviation produced by the first prism, deviation produced by the second prism. Deviation produced by the first prism, I1 plus I2 minus A1. Deviation produced by the second prism will be I3 plus I4 minus A2. I1 value we don't know. For that we'll apply the Snell's law. Sin I1 equal to mu1 sin R1. We know R1 value. We know mu1 4 by 3 sine of 37 degrees. So we'll get the I1. We know at minimum deviation I1 should be equal to I2 equal to 53 degrees. Condition for minimum deviation. Okay, so now we know I1, I2, this one. So what about the I3 is 0? So we'll substitute this one. I1 will be 53. Only I4 is needed. How to calculate I4? Mu2 sin R4 equal to sin I4. Mu2 is 4 by 3 sin I4. Solving this, we'll get the I4 as 53 degrees. So this will be I4 will be 53 degrees. A2 will be 37. This will be net deviation. (32 degrees plus 16, 48 degrees clockwise). They're just simple. Prisms can be like this. Usually we did only with one prism. Two prisms can be like this. Even if this ray is not incident, normally also can manage. Next one. Light traveling in air falls at an angle of incidence 2 degree on one of refracting surfaces. The medium on other side is water. Traveling in air falls at an angle of incidence 2 degree on refracting surface prism of refractiveness and refracting angle 4 degree is the angle of this small angle. This is a normal 2 degrees There's a glass, there's a water, there's a air. Find the deviation produced by the prism. I think let this be the R1, R2. Let this be I2. Let this be I1. I1 equal to 2 degree. Angle of prism 4 degrees. So the deviation sine I1 equal to mu g sine R1. So I1 equal to mu g R1. Mu g sine R2 equal to mu w sine R2. For small angle of prisms, mu g R2 equal to mu w I2. So what is the deviation? Deviation will be I1 minus R1. It is moving from rare to denser. So angle of incidence minus angle of refraction. It is moving from denser to rarer. So angle of emergent minus incident angle. So we have the values here. I1 equal to mu g R1 minus R1 plus R1 plus R2 equal to 4 degrees. So what is I2? We have to calculate the deviation, no? I2 will be mu g R2 by mu w minus R2. R1 equal to mu g minus 1. R2 equal to we know I1, we know mu g will get R1. If you substitute that here, we'll get R2. Then R1, R2 values, it has to be substituted. For what is further, R1 will be I1 by mu g. R2 will be 4 minus R1. This step I'll rewrite. R1 will be I1 by mu g. We'll get it here. Now substitute the R1. R1 is again I1 by mu g. 4 degree. R1 will be this is a deviation. Solve this. You have to solve this one. Okay, work out. I'll go for next problem. Read the question. 3 prisms are there. Huh? Already we have done one problem of 3 prisms. So one more problem I brought it here. The refractive indices of the crown glass for violet and red lights are respective, and those of the flint glass are a narrow beam of white light is incident at small angle of incidence on the shown combination of thin prism. Find the value of alpha, this angle, for which the mean deviation of the incident beam is zero. Also calculate the magnitude of dispersion produced by the combination. So one thing is clear that the mean deviation is zero. That mean deviation means the deviation suffered due to yellow color light. So directly we'll go for the net deviation will be due to 1, 2, 3. Mu I minus 1 into 4 degree, mu I double dash minus 1 into alpha plus mu I double dash minus 1 into 2 degrees. This should be equal to 0. What is mu I? For we don't know mu I, no? Mu I is given by for the crown glass. We should calculate the mu I, no? Okay, both are crown, no? Triple dash. Yeah. Mu I dash will be equal to mu V dash plus mu R dash by 2. 1.51. So this should be equal to 1.5. Mu I double dash will be equal to mu V double dash. For flint, it will be 1.77. Okay, this one. So like this, we'll get it here. 1.77, 1.5. Average, how much will be? 1.51, 1.49, 0, 1, 0, 2, 3, 1.50, 1.77, 1.73, 0, 1, 5, 3.5 divided by 2, 1.75. Huh? Oh, let me check the calculation. Huh? 1.77 plus 1.73, 3.5 divided by 2, 1.75. Okay, now we got that. Okay, lightly substitute that one. 0 equal to mu I dash 1.51 minus 4 degrees into alpha plus 1.5 minus 1 into 2 degrees. Solving this will get the alpha. Alpha will be 4 degrees. He's asking next the dispersion. How you take the dispersion? Dispersion produced by the first prism, second prism, third prism. First prism will be mu V dash minus mu R dash into 4 degrees. This will be second prism mu V double dash mu R double dash into alpha. Solving this will end up minus 0.04 degree. What do you mean by that? If minus negative sign indicates violet on top, the final spectrum will be, this will be violet, and somewhere this will be the red. This will be the final spectrum. This is the incident violet. Just problem is very simple, huh? Nothing to do. You don't. If you want to show all the, it will split up here. Huh? Then okay, the ray will go like this here. So the violet will be on top. Negative means the violet will be on the top. So in the spectrum, so when you get the net dispersion, so what we calculated is net dispersion. Net dispersion positive means violet will be below the red. Net dispersion negative means violet will be above the violet on top. Violet above the red. Sir, I am not understanding. Okay, we'll do one thing. If you take the prism in the spectrum, if you get red, this is violet. Dispersion will be positive. If you get this a violet, this a red, dispersion will be negative. Violet on top of red, dispersion negative. Violet below the red, dispersion will be positive. Okay, there's a convention to remember. Okay, now, yeah, this is something. A real object is kept. I want the position of the image, that one. A point object is kept. So where the image will be formed, image of this particular thing has to be located here. So this is the first time I'm bringing a problem where an point object is brought, because all the problems we took like area of light is incident on a prism. So here we have a point object, real object is kept. Hmm? Where will be the position of the image? So what the prism will it form real or virtual image is what we are trying to learn here. And this will be very important, will help us a lot when we go for biprisms, when we learn biprisms. We'll be using this particular concept here in wave optics. Therefore, biprism, to produce the coherent sources, we use the prism. I think I should permit students to at least think. So what will happen to the rays? So we'll start with the ray diagram. The ray, it's a thin prism. I'll write the question. A point object is kept nearby a thin prism as shown. Find the location and nature of image. So the ray as a thin prism, we'll just take the all the reflections with respect to the midpoint of the prism. Hmm? Now the ray after refraction will pass like this. Now you send another ray. It will also undergo refraction. Small angle prism. So you produce back this. This is what the image. Okay, this is ray 1. You can choose many number of rays, not that one. Then both the cases, what is the deviation produced will be delta. Here the deviation produced will be delta. Then this will be delta. This will be say y. So we know deviation produced by small angle prism mu minus 1 into A. What is the deviation? Tan delta. You go for triangle. Tan delta equal to y by L. So for small angle, delta will be small of few degrees. This one, look at this triangle here. So therefore this will become y by L. What is y equal to mu minus 1 A into N. Substitute here to substitute all angle of prisms, everything in terms of radians. Suppose say 10 angle of prism is 5 degrees. We have to express that in radians. Angle is in radians. Let's assume that A equal to 5 degrees. Then L equal to, I took this is L. L is equal to say 10 centimeters. Mu equal to 1.5. Let's look at the position of prism. Position of the image equal to angle will be, you have to convert this into radians. So 5 pi by 180 into L is how much? 10 centimeter. Solve this. You will get this as 5 pi by 36 centimeter. So the image will be virtual. So what prism does? If you keep a real point object, it will form a virtual image. Now we'll go for biprism. That's the same concept. Just now what we applied is for the two prisms. We'll first draw the ray diagram. A ray okay, fine. So this will produce back one image. This will produce back. This will be other image. So this is the angle of prism. This is y. This is y. What is the delta? This should be the delta. Then this should be the delta. Then this should be the delta. We have to calculate the, now what is the angle of prism? Angle of prism will be 90 degrees. So alpha by 2 plus 90 plus a equal to 180. Or pi by 2 will write it. This will be pi. So angle of prism will be pi minus pi by 2, pi plus alpha by 2. Pi minus alpha by 2. Okay, this is the expression for angle of prism. The deviation suffered by the ray should be equal to mu minus 1 into a. So this will be mu minus 1 into pi minus alpha by 2. Then tan theta. How to bring that one? Same biprism, in biprism what we use, the same formula should be applied here. Tan delta should be equal to y by L. It's a small angle prism. In the diagram it will appear it's a small angle prism. Some diagram. This will be calculations will be easier. So here it will go like this, the ray. We can take several rays. It'll be very easy for you. The calculations will be very much easier. Now you see this. This will be the deviation. No? Then this will be the deviation. If you want, you extend further. Let me bring that dotted line. Yeah. Okay. So what is tan delta here? The delta will be altogether. This is y, this is L, this delta. So tan delta equal to y by L, or delta equal to y by L. So y is equal to the same formula. Del y by L is equal to mu minus 1. This will be the images, I1 and I2. I1 and I2 are virtual images. We can calculate them. So therefore, if you for a biprism, two prisms they are combined here. So if you keep a point source at the apex, somewhere at the nearby apex here, at a distance L, a thin prism it is. Then we can calculate the position of those two images here. I think the mathematics, this will be much easier. With the red color ray of light, you are able to do the calculation very easily. This will be using in the wave optics, Fresnel biprism. Okay, kids, like we had the discussion on the prism problems. I think plenty of numericals is what I brought here to make you understand. Uh, I think in all, what are the basic idea of prism, the geometry, and the relationship between the angles. Then afterwards, we'll go for applying the Snell's law. Then we'll jump into the some prism ideas here. So this was the overall methodology of the prisms. I think I solved approximately around some 35 numericals are there. You check it. A wide varieties of 35 different numericals I brought it. So think on them, analyze it, so you'll be far better position. So in the next class, we'll go for the refraction at spherical surface. So I'll request everyone to share the app and the web information to all your fellow friends who need this particular help. It's a totally free. I just wanted to help each and every student, whether irrespective of you studying the one good college or the poor college, whatever be that one. So this information of the physics, what numerical analysis will going to help you a lot for competitive exams. Please do share with your friends. So it will be an helping hand. Okay, thank you all of you. Take care, kids. Bye. See you.